PhD in chemical engineering from Rice University, USA. Dr. Nair is a professional with over 35 years of experience, 22 of which has been as the CEO, President and CEO at Ingenio, which he has co-founded. Through his company, he has successfully applied the concept of process simulation based on twin digital concept to chemical process manufacturing, and thus successfully helping the digitization of plant operations. Now, his expertise includes specialized applied AI engineering and harnessing the power of advanced analytics and technologies like first principle based modeling, machine learning, smart data platform, and more. Before engineering, he held various key positions such as business and corporate development, coordinator of the management board, and senior VP at Cadila. Before Cadila, he also founded Profit Technologies, a management consultancy firm for the process industry. And he has also held multiple roles such as analyst, project manager, director of project development, and VP at ChemShare. He also won the AISL Lumiere Award, which recognizes talents across industries in November 2022 for established business leaders. He was also included as one of the 30 as an icons of transformation in India in profitable book publication. We are very fortunate enough to have him here today. Today, his talk is titled Leveraging Applied AI for Smart Decisions in Process Manufacturing. Over to you, sir. Thank you.
Thank you, Nitin.
Thank you, sir.
Let me share my screen. I have a presentation I'll walk through, and we can then start from there. Just let me know if you're able to see my screen. Are you able to see my screen?
Not yet, sir. Yes, sir, we can.
Okay, good.
Okay.
And you can also hear me.
Yes, sir.
Great. So today, what I'm going to do is, walk you through. I mean, instead of getting down into, into the depths of the forest, we'll take a look at the overall forest, being the whole area of applied AI in process manufacturing. So let me, before I get started, give you a very brief idea of what we do at Ingenio. Let me see if I can. So quick overview of the work areas we are in. We traditionally have, when we first started, we work with a lot of process manufacturing companies across the globe. We first started in the US, and then, of course, we've supported plants throughout the world in optimal asset effectiveness. helping them with throughput, yield, availability through deep analysis. Um, Process safety is another area we've been involved with for over 20 years, specialized in PSM, process safety management, risk-based process safety. Engineering is another division we have. And sustainability is a more recent division where we are actually jointly developing some technologies in that area. But today's focus area is the fifth business unit we have, which is the applied AI solutions. We have two distinct subdivisions under this group. One is the AI projects division, where we have about 400 people or so, just focusing on delivering different kinds of AI-based projects, all to mainly process manufacturers. We have a separate group of about maybe 50 people or so just doing product development. And we deal with things like digital twins, big data analytics, different kinds of AI. So that's our background. So to give you a brief idea of the experience, where we're coming from in this whole AI area, um, we have to date delivered more than 50 digital solutions, more than 500 use cases across different regions. And like I said, mainly in refining, oil and gas, petrochemicals, different kinds of use cases, whether it's for reliability, safety, efficiency, and so on. So if you look at it, the experience we've had starting in 2001 when we first started the company, uh, delivering remote analysis to all these different process manufacturing facilities really gave us a jump start. Because at the end of the day, we were even then using a lot of, apart from fundamental models, we were also using a lot of data-driven models. And that nicely kind of folded into the whole machine learning area, which was something that started getting popularized under AI about a decade back. And so it was around 2014, by virtue of having several clients, one of the clients came to us and really had us get started in this area. And that was really when we did our first deployment. And I'll share some use cases with you towards the end of this presentation. So today, what I will be doing is running you through. I won't, like I said, I won't get into specific algorithms or specific details, but I'll give you a bird's eye view based on our first-hand experience of what is applied AI. And all the while, I'll kind of keep relating it to the process manufacturing vertical. So why do you really need to look at this area? Where is it really used? What is it? What is it that it is being used for? And most of my presentation, I will really kind of dig a little deeper into the how it is done, rather than getting into specifics of individual algorithms. I'll give you a complete overview of an end-to-end application, and this is, like I said, based on first-hand experience, successfully deploying these solutions and developing, some of the software that we have. So this is really what I will walk you through, and this will be the main crux of my presentation today. I will, at the end, also kind of share some snapshot of solutions that we have implemented and the type of benefits that we've seen coming out of these kind of implementations. So moving forward, what is it that an applied AI solution, really, if you take a look at where does it fit in? So if you look at chemical plants, if you look at, there's a physical part of it, the asset that you have, which you're operating, where you have sensors and instruments, which really is the sense of touch, if you will, or sense of sight into what is really happening within the plants. Everything happens within pipes. So it's these sensors and instruments that measure temperatures, pressures, compositions, flow rates that really give you a sense of what is happening in the whole conversion process in these process manufacturing facilities. Unlike discrete manufacturing, where the whole transformation is happening in front of your eyes, here everything is within pipes. And so these sensors really are so important in kind of giving us a sense into what is happening. Then things like the product characteristic, product quality, the product itself, the plant, different equipment. So that's the physical space which is there. Then you have a virtual part of this. How do you, the whole idea in AI is a big part of it is digital twin in these applications for process manufacturing. And so you're almost creating a virtual space that mimics what is happening in this physical space uh, that is within the pipes and so on. That is one aspect of it. And within that, you have things like the smart sensors, data management, platforms, the whole algorithms, different kinds of analytics. The fundamental models have also form a part of the applied AI space. And things like visualization, then the communication, the communicating, outside of the immediate facility. So that forms the virtual space. Digital twin is really a virtual replica of the plant behavior. And there are different kinds of digital twins. Some people refer to digital twins as a physical replica of what the plant really looks like from a design perspective. A lot of what we do to try and mimic behavior of the process and the plant is trying to model what is happening within the plant. So once you have something like that, and I'll get into more detail of how all these blocks fit in and what they really do. What it is able to provide, one, on a real-time basis, based on the data that is constantly being taken from the physical assets. It gives augmented intelligence, enabling an operator or engineer or management to really have a feel of what is happening, what the anomalies could be, what can be done, how do you optimize. So these are all the kind of decisions that can be pulled out from a virtual system. It can either be completely automated or it could go through a human in the loop. The other aspect of this is the operator or a manager wanting to know something about the asset. And with AI now, with these kind of applications, you're able to get these answers pretty much at your fingertips. So that's really the bigger picture of where this fits in and what an AI application in this space looks like. The results would be improvement in the physical space of, when it comes to production, more efficient operations, reliability, sustainability, safety, and so on. So I'll take a pause here and I'll ask if there are any questions, please, or if there are any doubts as we're progressing, please let me know. So moving forward, let's look at the why and where. I mean, why do we need these applied AI solutions? What comes out of it is the ability to automate rote tasks, not jobs, but tasks. Do more things faster and better through better analysis, faster analysis, and faster communication, broader communication, just-in-time intelligence that comes out of it with actionable insights for enhanced decision making, faster learning. I mean, a lot of the times we don't know what we don't know, and what with these kind of applications, a lot of these items come to the surface. So making known sometimes what we don't know, and basically raising the bar on what people can do and need to do. So essentially, it's really a way of revolutionizing the way businesses has always been conducted in this area, enabling new revenue streams, better collaboration, better user experience, better decisions. I mean, the whole idea is, humans are very important, and it's the collaboration that really gives you a lot of the benefits. One of the things I always say is good analysis answers questions, but great analysis prompts us to ask new and better questions. So, which is what some of these systems enable you to do, because you can ask a question, you get an answer that triggers your imagination, triggers your thought to ask much better questions. So that is something which is a huge advantage. And this is what we've seen, which is oftentimes not really listed as one of the benefits coming out of this, but there's a huge amount of benefit that we've seen from this application from in this respect. So in other words, applied AI can do things that a human being can't do. The human beings can do things applied AI can't do. Together, we can do amazing things. So that's really the bottom line of applied AI. So in the process manufacturing space, there are various different places where we've been applying this. Safety is one area, very important, because you are able to, closer to real time, be able to take a look at what is happening, get warnings way in advance of a potential hazard, and very quickly rank the risk and the probability of something happening, and then taking a proactive action. Likewise with production, through the remote tracking, reliability, being able to more in a more predictive way, take care of the maintenance before, say, a breakdown happens. Enhance yields, enhanced efficiencies, uh, through better monitoring. You have a better handle on how you can manage emissions. You can operate the plant a lot better. So these are all areas where applied AI has a very, very important space in the process management application. So now let's go more into the how of things. So I'll take you through what an applied AI solution looks like, what are the components, and some implementation examples. So when you look at an end-to-end applied AI solution, data is the fuel. This is where you start with. And this is something that there's an abundance of, particularly in process manufacturing facilities. A lot of data has been collected ever since you had DCS systems and all go in, and then historians, you have a lot of data that is really being collected. But historically, maybe 90% of this data has just been archived, even though there are gems of information in there. So this is the data that today can be tapped using more of these, AI-based, machine learning-based analysis. Data platform is the being able to really handle the data, process it, clean it up, and store it in a convenient way for ready access by these expert AI models. Now, these AI models, there are several layers, and I'll come to that. You have a lot of these generic algorithms, generic foundation models. Um, Algorithms can be as simple as least squares kind of thing, or pattern recognition algorithms, or even when you come further to the generative AI, some of the foundation models that have been in vogue over the last year or two, that has been very much in the news, and almost everyone has tapped into it and tried and used it in some way or the other. So that really feeds in, and I'll come later to what do we mean by expert AI models, which and how all these combine together. So data really fuels all this. So it fuels the value creation, and the data has to be effectively collected, stored, curated, annotated. So the raw data does nothing. I mean, it cannot be utilized, and that we've seen over the last multiple decades, even though the data was there. And that is followed by model development and implementation to actually try and utilize this data in a fruitful manner. The other next important aspect is, okay, you do the analysis, you take the data, synthesize it, analyze it, but if it's just there and you do know nothing about it, um, no action can be taken. So that is where the user interface and how it is fed to the user becomes so important. That is where the user interface and the way it is used is a very important aspect as well, because that is where actions get driven. So translating the processed model insights into accessible formats enables humans and machine to take value generating actions. So that is another very important aspect of when you talk of an applied AI solution as a whole, end to end. Another equally important aspect is how does all this get integrated with a workflow? So, okay, you get insights, you get results of the analysis. What do you do with it? You take it, what is the flow? Traditionally, every plant, there are systems. There's a certain way the work flows from traditionally how you got the insights could have been different. Now you're getting closer to real-time insights, closer to real-time prescriptions. How do you utilize it all the way up to being able to take an action, and then obviously monitoring the outcome and seeing if you can improve beyond that outcome. So that's really the workflow aspect of it, and how that is deeply integrated with this whole system is as important. If you really, at the end of the day, you're doing all this to get a step jump in the way the convenience of doing things or getting value out of all this. And the step beyond that is what today you hear of agentic AI being everything working autonomously. So having more of an expert system that automates or runs in an autonomous way and implements things automatically. So this is something that the surface is being scratched today, and a lot of progress is being made in this area. So broadly, if you look at end-to-end applied AI solution, this are the main components, and this is what it would look like. It's not just a model, it's not just data, it's all these pieces woven together that is so, so important to ultimately have a solution that delivers value. So delving a little deeper or into some of these components, when you talk of data, historically, like I said, there's always been a lot of data that has always been available. And some of the data is very structured, like numbers, tables, relational databases. And there's also a lot of unstructured information in the form of notes, whether it's handwritten or notes that's typed in. And then there are all kinds of design documents. So there's all kinds of data that is available. A lot of the time, it's not in one place. So then there's real-time data, or data that is more batch, or there's a whole historical reams and reams of data that are available. The form would be there are either numbers, text, images, videos, could be audio recordings. So what AI has done really, the real development that has taken place is our ability to take one or more of these items, the forms of data, and be able to analyze it. And that's the real development that has happened. Data platforms, another very equally important component, because that is really the first step where the data is taken. It's stored in a manner where it's equally easily accessible and usable. Some of the initial processing is done there, the contextualization, orchestration of various analysis tools, pulling of specialized apps. So these are all things that the data platform has evolved into being able to do these days. And then there's a user interface. And again, there are various different modalities of engagement. It could either be static, interactive. The interaction mechanism could be in terms of a screen output that you get, or it could be a query that is asked as a voice prompt, or you're typing it in to try and do scenario analysis, what ifs to get an answer, or agentic in nature, where you actually set an objective, press a button, and it comes back and actually does a lot of the things that otherwise you will have to do step by step. The consumption model could be real time or in a batch mode. The output types again could be visual, audio, spatial, and sensory is really state of the art. Not a whole lot is really being done today in our industry, but a lot of work is happening in the space to try and analyze sensory type of data. Um, and then the workflow, the augmented workflow really is the whole flow from getting insights to prescription, decision, and the status. So this is kind of what each of those blocks really entail. So now let me go to the next step of AI. I mean, what's really, AI has evolved. It is not a new term. This term has been around for almost 70 years. Um, but it's only in the last decade where, on account of a lot of the development in the step jump in the computing power, in the speed of communication, in the data storage costs, that a lot of developments started happening in this area. And so you have multiple layers. You have the traditional AI in terms of a lot of machine learning algorithms. Again, machine learning is not new. I mean, we've been doing data-driven analysis for several years now, and even when from whenever we started doing chemical engineering. But that really took a fillip when you had step jumps in these computational power and so on. And so the ML and deep learning algorithms as we know it really form the base for what people today refer to as traditional AI, utilization of a lot of these data-driven algorithms, where the whole model is you feed data. There is a model that you have trained based on lots of data, and you've tested and trained it. And so it's able to, when you feed in new data, the model is able to reproduce or predict. So that's the traditional AI. The next level, which really is of more recent vintage, that we started hearing a lot more about, particularly in terms of results coming out of it. And ChatGPT, OpenAI really popularized a lot of these applications in the Gen AI space, where the whole idea there is you have a model. People have heard of these large language models. You send a query and you get an answer based on these models that have been developed over lots and lots of data across the internet or wherever the source is. Or it could even be specialized data, because today people talk of retrieval augmented generation, where you're able to actually not just rely on a very generic large language model which has been trained based on whatever is available in the internet. Specialized domain information can be fed in using things like techniques like the RAG and LoRa to really answer a question a little more, with the domain inputs. So that's the whole area of generative AI, where you're generating something. So like you could give a sentence and it can complete it for you based on what it has seen, uh, from the internet, or what the lots of data that it has learned from. And today there's a lot of talk of agentic AI, and all that really is a coordination of a lot of these first two types of models, or even traditional fundamental models, different kinds of things, each of which is really called an agent. And I have a slide later on diving a little deeper into the space of agents. And you have something being coordinated, and where automated action is taken based on inputs from these various agents. And so, these two things we have, whether it's a traditional AI model or a generative AI model, those are really types of agents. It could form one of these orange circles here, or there could be several other examples of agents, which are all pulled together and coordinated for the machine to take automated actions. So based on what we've heard, uh, these are the types of AI and the evolution of AI over the recent past that we have that we're utilizing in a lot of applications these days. So when you really look at artificial intelligence, I mean, a lot of people just, when you talk of artificial intelligence, they think only of an LLM, or they only think of, because that's very much in the news. But AI, like I said, has been around for so long. And so even a lot of what have been doing, whether it's with process simulators or rule-based models, actually is a subset of the AI. And of course, machine learning, which really started making huge strides over the last few years, mainly in terms of applications, is another big area, which has enabled closer to real-time analysis for us. And then all these LLMs and ChatGPT, all these are subsets. So that's really the whole domain of AI. And the whole key part is the domain expertise, uh, being able to select which technique to use and be tailored for specific use cases is really the key. Initially, when a lot of these things were popularized, there was a whole big drive that, hey, I want the latest and greatest algorithm, and that's going to solve everything for me. That resulted in a lot of disappointment and failures. And this is something, we have seen extensively with a lot of the clients we worked with. And, we have been successfully able to, help a lot of our clients who have been with us for several years in this area. But this is something that is a very important aspect of being able to really extract value out of AI. So I'll kind of be harping on this whole area of how do you extract value from an applied AI solution, instead of just talking of a technology, a dazzling technology that is going to be a panacea for everything. So that is the key. At the end of the day, how do you put all this together to really get value out of it? So if you're looking again in the process manufacturing domain, and this would be true for several different domains, AI really consists of multiple layers. There's a lot of talk of with NVIDIA and so on. They're making these chips that are really developing in leaps and bounds in what can be handled. So there's a hardware aspect, which is the base. Then you heard of data platforms over the last several years, whether it's on the generative AI side or even platforms to handle more of the traditional AI and capture of data. And then there's all these models, generic models, whether it's using generic algorithms or foundation models, whether it's like the Chat GPT or Gemini or Llama. So that's another layer, which I call horizontal generic models, whether traditional or generative. So just using these two, there was a perception that, wow, we can just feed data to it and we'll get all kinds of results, which is really where people started getting a little disappointed. You got into the trough of disillusionment. For a lot of the early adopters started facing some of that. And so there are some layers that in very specialized vertical applications like process manufacturing, um, there is a gap. So it is almost like you have built a solid portion of a bridge, but not completed it. So one of the key things here is one aspect is a lot of these generic models are trained on readily available data. And a lot of the times, specialized data that is required to train a model may not be readily available, just going into the internet, or a lot of it is largely privately held. So that's one part of it. So it is very important to address this need in these specialized vertical applications to be able to get the performance, the value coming out of these kind of applications. So this is a very important layer where you have specialized agents, and I'll give you some examples of these specialized agents. So that's a whole layer that is leverages these base data platforms or foundation models. Um, and even in the data platform area, there's some specialized aspects to that for each vertical application. Specialized data handling. So you know that what your type of like temperatures, pressures, compositions, you have some based on experience, you know what some of the patterns could be like or what the typical errors could be. So you can give it a jump start and you can more easily handle some of those things, curate some of these things for specified use cases, because you could have totally irrelevant data, even though there's lots of data to solve a particular use case. So this is where some of the domain expertise comes in, and being able to pull that and integrate this with these base horizontal models is a very important step. And then also having some of these domain specific reasoning models. There's a wealth of information with process simulators, with the chemical engineering area knowledge. Same as with other facets of engineering. There's a lot of this knowledge. How do you leverage that? And if you do that effectively, whether it's at the time of training these ML models or even as surrogate models, it makes a whole lot of difference in the end application, in the application which is done today. Another very important aspect, which is often completely missed out and was done by the lot of the early adopters, had the perception that, hey, the technology, it's plug and play, you just plug it in and it's going to give me all kinds of results. It's far from the truth. There's a lot of AI engineering that really goes in to be able to deploy uh, a solution that is really at the end of the day able to give you the value, which requires not just data science skills or IT skills, also a lot of domain skills, all working hand in hand. A lot of rigorous testing is very important. And that is important because that's what really would be able to only give you the value. And that is this kind of testing and elaborate training and so on with the domain expertise going in is extremely critical for the robustness of the solution and hence the credibility from a user perspective. Because if a solution starts spewing out results that are clearly not absurd or clearly not correct, which someone with experience will be able to immediately identify, the solution is just going to gather dust on a shelf somewhere. And so in these early adoption times, it is so important to make sure this upfront AI engineering type work is really done. When it comes to AI model development, it's a highly iterative process. So a robust ML model building process would start with business understanding, data understanding, outcome understanding, and then you go into being able to prepare, have the relevant data come in, and then the model generation, a lot of the training, and again, like I said, you validate it, and there is a level of iteration here to test it abundantly to make sure when it goes into production that you're fairly certain that it is robust and it's going to provide answers. Certainly, I mean, there's some level of further improvement that will happen even after it goes into production, but it cannot be, it should be less than 5%, if not lesser. So it's the iterative model development, which is so important if you really want the usage to happen and for the sustained use of these kind of solutions. So these kind of models actually take time to build. It cannot, there's a lot of, talk about, hey, you can develop these models in a week, plug, and it's off. But, those kind of models really may create a bad name. And then, there are additional things like auto run, the monitoring aspects, and, having, even after it goes into production, a mechanism to really get feedback and keep improving upon these models. So there's a whole retraining process that has to be put in place. And always, like I said, links to the other co-enabling components of an applied AI solution, whether it's the platform, the business intelligence interfaces, the workflows, the collaboration tools, and how the decision is going to be taken. So the integration with all that is really what completes a solution and makes it able to deliver the value that you're looking at. So, on a lighter note, some of the pitfalls of not really taking, including the data engineering and purely being technology focused, it has to be wrapped around with what the AI engineering, which is data engineering, decision engineering, advanced analytics, that has to wrap around all these technology pieces, because otherwise you could very easily, when it's extrapolated, get some of these absurd kind of results. To extract value, the focus really needs to be not just about reporting results, but how do I influence outcomes? And that's one of the key starting points is you have a set of problems that may be suitable for solving using data. Then you have a set of problems that matter to your business. So the intersection of this is really the problems to focus on. So a lot of the times, just getting enamored by technology, there have been problems that were solved that may have had no business value as such, minimal business value, or no improved convenience or improved way of doing things. And so this is where once that goes into place, then there's disappointment. So being able to define this and managing that interconnectivity of use cases and solutions within a domain is one of the keys in when you go to actually try and utilize these technologies and start deploying it to make it useful. So beyond the data collection, data validation, model implementation, there's obviously the data preparation, the data strategy, which is so important, and the last mile. How do you take the actions? How do you really start utilizing it? There's a people-related process there as well, is what we have found time and again. And so that last mile cannot be ignored because oftentimes things stumble over there, even though the solution that is put in place may be excellent. So this is where working with an applied AI solution provider who has combination of domain expertise facilitates this leap to happen. And this is what we found time and again happening. So it's basically all about deploying the appropriate technology, reshaping the workflows and functions, and hence enhancing. And then the next step is really utilizing that to trigger your imagination for newer and better inventions. Just to give you some very simple examples, there are a whole lot of agents that are available in your, the B2C or the business to consumer. You have seen a lot of things like, a travel booking agent. That's a very simple agent. So likewise, in our space, in process manufacturing, these are some very simple examples of agents. One is dynamic benchmarking. It's an agent where an operator, uh, can look at exactly the current situation, and at their fingertips, they have in front of them where, with the same set of conditions and environment, where they may have operated much better historically. So the historical best. And then it kind of prescribes, hey, this is how you can make changes to achieve what you achieved historically. Because oftentimes, I mean, it may sound something that, hey, you've already done it, but it doesn't mean that automatically that happens in a plant. It is so dependent on the operator and the team that is working. So that is readily made available. So that's one kind of an agent, which takes the first step, even beyond talking of optimization, to keep ensuring that you can keep operating at the best level that was possible. And if that is not possible because of some inherent limitation due to asset changes or fouling or so on, that is also pointed out, and what is the best that can be done. So that's really this whole dynamic benchmarking. You're constantly benchmarking against your previous best and making sure that insight is given and the prescription is given to be able to operate there. Likewise, equipment health, constantly looking at the health of the equipment and, showing if there's something that is really happening, which is unseen, which could prevent or enable a proactive action to be taken so that you don't have an equipment breakdown. Likewise, with instruments or process deviation itself. So these are all specialized agents that have a combination of data, data analytics, as well as some level of the fundamentals that have been incorporated into it. So when you comparing technology solution versus a pure technology focus, like I said, the generic horizontal technology stack. I'm just kind of summarizing what we spoke about in these past few slides. The generic horizontal stack alone is like an incomplete bridge. What you really require, one, is an end-to-end applied AI pipeline solution. And two, the specialized domain agents and AI engineering that goes around this to make sure this end-to-end pipeline solution happens. And this is how you can really complete that applied AI solution bridge. So let me tell you a little bit about the agentic AI. What is it? I mean, there's been a lot of talk of agentic AI, and a lot of people directly want to jump into agentic AI. It's really a step-by-step process, and I'll show in what really agentic AI means and where, our experience, the best way to really start utilizing it, step-by-step process. What does an agentic AI concept enable? It's an evolution from predictive models and co-pilots to more autonomous, goal-driven systems in enterprises. Autonomous systems capable of planning, executing, and delivering results. Enhanced functionality and adaptability, efficient outcomes across applications. What does it do? Autonomous information gathering and analysis, operates in real time, navigating the web and specialized databases, processing diverse data types, utilizes a variety of tools that could include foundation models to meet certain objectives that you specify. Uh, Also by remembering the context and history, as part of the planning, optimizes to maximize utility and improves learning over time. So if you look at it broadly in a very simplistic way, you have at a very high level an agentic AI coordinator, various agents. I give you examples of some of the agents in our industry, which are fed with data. And each agent could be a combination of what you see on the left-hand side. It could be something that could be just a traditional AI-driven model or a combination of that with fundamental models or with more generative AI models. There's a memory aspect, context aspect, knowledge guardrails. So that really could be an agent. It could be one or more of these things incorporated into any given agent. So this is really the whole idea behind an agentic AI is so being able to pull something like this together again requires some level of understanding of the domain to be able to meet a certain objective or specification in automating a workflow. So you need to be very familiar with the workflow and whether you can improve upon it or just use the same workflow and do it automatically. So it's a combination of these fundamental models, the ML, predictive ML models, these generative AI models with the agentic AI and some level of context engineering, the AI engineering portion, which could really give you more of the reasoning models, which is really where this whole area is moving towards, because this is where you can start getting more and more value. So for these this is not something you would do on day one when you get into start doing something like this. And so we worked with numerous customers, and our experience has been the best way to really graduate towards it is one, even before you talk of autonomous operations, put in these specialized end-to-end applications for very defined use cases, and then train users on the specialized on the specialized agents and make sure that it is getting utilized and make that part of their work process and and it becomes part of their habit to really utilize that. So that's a very important first step. Easily said, not always, automatically. It doesn't happen automatically. And so there's a whole people process as well in getting to that level. But that has to start happening before you really are able to take it to the next level where that usage can be standardized and there's a drive to even at the user level to capture value and being able to extract value from these individual agents that are already there. So getting the human thinking in that way goes a long ways in getting the buy-in even when you start to go for autonomous operation. And this we found to be an extremely important set of couple of steps before you can get into really making it a lot more autonomous. So this is where the last step would be to implement software that automates the use of these agents, streamlines workflows. Users will be able to define broader objectives from the experience from these first two. They're able to actually get a lot more value and ability to define what the agentic AI really should be doing and collaborate, and what agents, sub-agents it could collaborate with and so on can be better done is really what we have found. So this was kind of a template for based on our experience that we have seen. So that's a little bit I wanted to share about, what whole applied AI means, taking a look at it from a larger, much more of an overview, higher level perspective, but giving you a end-to-end view, because oftentimes there's a lot of talk of individual aspects of this, and you lose sight of the forest for the trees. And so this is what I've tried to do, and share this based on our experience. I'll quickly run you through some of the snapshots from applications that we've done and some of the results that we have seen. This was one of our very early implementations where we implemented, this was a midstream operation in the US. The company operating one of the largest NGL pipeline networks in the country. We deployed digital twins for their operations for 40 sites. And there was a central, control center where a lot of these results from these digital twins from all these 40 sites was coming in, and they were synthesized, not just for the individual site, but also as a whole. So the augmented intelligence from the solution really helped with the profitability in the very first year. This was actually uh, published, and so there are a lot of benefits coming from the proper implementation and utilization of these kind of systems. And this was a classic example of the digital twin application. Another example, this was a petrochemical facility where it was actually a combination of digital twins and a system being implemented, along with a lot of remote support from the client end user, as well as we also provided a level of support utilizing this kind of an end-to-end solution to be able to deliver insights and actions, and a lot of improvements in production efficiencies and so on. Another example was with in a refinery. One of the areas was the delayed coker, where this kind of data-driven modeling was able to actually characterize and predict the furnace run lengths. And so in the delayed coker, you have furnace and you have these coke drums where the coke keeps building up. And even the furnace can only be run for a certain length of time, after which it has to be decoked on the furnace side. And so there's one thing where you can run blind, and just when it all gets cooked up, you can start. But that's a very ad hoc way of doing it. There have been systems and SOPs set in place where, based on experience, there's an SOP set that, hey, after this length of time, you can stop, decoke, and then take it out of operation and put it back. But what the AI system really enables is you get a real-time view of exactly what the state of coking is, and in which pipe of the furnace. I'll show you a visual where that is very readily seen, which tubes even within the furnace is getting coked, and how you can utilize the uncoked tubes to get a greater furnace run length, or tap greater use into the furnace. Um, Likewise with the coke drum. Uh, the coke drums have to be constantly switched. You would have 2 drums or 4 drums, or so there's a switching that happens once the coke starts filling the drums in these delayed cokers. And it's very difficult to get an exact, even though there are level indicators, those are obnoxious to fail. And so you never have a clear indication of the level. And so people normally run it very conservatively. And so the drum cycle time is a lot faster than it could be. So this is where the AI could help, not just with the level indicator, using a lot of associated measurements to have a better indication of where that coke level is, and you can really start running it safely up to a limit and avoid any kind of fouling through, kind of overhead fines escaping into the outside the drum and fouling everything downstream. So these are the kinds of benefits that they saw from this application in very specifically in a delayed coker. The AGI variable, AGI is a Hargrove index. It's one of the quality measures of the coke. Again, being able to characterize that a lot better, utilizing a lot of the associated measurements and soft sensors. This was another application with gasifiers. There were 80 gasifiers. And here the main benefit and application use case where they could utilize these machine learning models was in maintenance, because these fluidized beds are notorious for they have to be taken out, and they have to be there's maintenance process that happens, and normally there's very little warning. And so this is where these machine learning models were able to give a 30-day alert in advance, which through their operation, they found it to be fairly accurate. And that helped in a 7% improvement in asset availability. Another example, live steam balance. Really, this is again a refinery example where you had a bird's eye view with drill down details possible of really what the whole steam system looks like, the consumers as well as the steam generators, and really operating that in a lot more efficiently. And that really helped reduce the steam requirement by a few percent points, and it basically gives a better view into the operation of the entire utility system. Again, the things like dynamic benchmarking and all play a very important role here, because you're able to actually run the system. You never run it below something where you may have run it a lot better in the past. Here's another example. This is actually a furnace, and this was in a VCM facility. You get, again, a lot of different kinds of information which you can further drill down into, whether it's emissions calculations, real-time fuel saving calculations. You have what-if capabilities, and so on. And this, again, helped run length of these furnaces, improve production as a result, improve furnace stability. Give you a quick view of an enterprise-wide application of this applied AI based solutions uh, implemented for plant efficiency, energy optimization, reliability, efficiencies. So here is a quick view of for someone very senior to look at all their 12 sites. This is a large petrochemical conglomerate These numbers had to be sanitized because of confidentiality requirements, but essentially this is really the type of information that is immediately seen. And these KPIs are focused on plant efficiency, health and safety, reliability, and sustainability. A bird's eye view across all the sites, different geographies, and it highlights some of the key performance indicators and marks in red where an attention is required. And this you can click on. I mean, even though this is a snapshot here, uh, you can click on this and drill down into further and further levels of detail. So I've just picked up snapshots and I'm showing it here. So you can drill down to the to a site level. So one site, in this particular site, there are 5 plants. You have ethylene, HDP, LDP, ethylene oxide. Again, the same KPIs with a little more level of detail. As you go drill down, you start seeing more and more detail and maybe a little more prescriptions also coming in with different kinds of KPIs with highlights if something needs to be focused on. And then when you drill down further, you go to a plant level, and then you can see each asset, whether it's a furnace, CGC, acetylene reactor, or further downstream units. Again, the same KPIs being looked at with some level of prescriptions coming in. And then you go down to the equipment level, where again, you can predict areas where some things may be early warnings. And it also immediately shows the level of risk or the level of criticality of what this is going to, what this could lead to, and where immediate attention may be required. So prioritizing that. So this is the kind of information that is really projected in an enterprise-wide model. Behind the scenes, there's a lot of computation. It's not just taking raw data and throwing it into screens. There's a lot of computation before an analysis before you can kind of populate something like this. Likewise, with again at the compressor level, looking at further drill down of what the health index of that whole equipment, where it stands, and what, if any, actions need to be taken. Again, with respect to these same kind of KPIs: efficiency, health and safety, reliability, and sustainability. So this is a closer snapshot of the type of views that even an operator level person can see. And this is where I was talking about in a furnace. You see those red dots. I mean, those are all tubes, different furnace tubes. The red dots really show that it's fairly fouled. So visually, the operator gets immediate feedback of where the status of how this is happening. And it gives the basis on which maybe more the feed would be stopped to these tubes, and it would be preferentially sent to some of these other tubes. Now, without an explanation or interpretation of why that is happening, an operator may just override it. And so this kind of interpretation is so important, even if it's automated, for an operator to understand really why something is happening. And then you have this being ability to, since all this data is available from different sites, you have, say, you can take one particular asset like a compressor or heat exchanger, compare it across various similar facilities, say across all ethylene facilities across these 12 sites, and see, compare and contrast, how they vary, and if so, what causes the variation, and can something better be done in the other sites versus a flagship site. The Gen AI application sitting above this really enables extraction of information at a much more convenient level. And there are 3 things I've highlighted. One is where the generative AI is able to, you can ask it a question. It is set up so that it can pull the right screen. So instead of your knowing how to drill down or where to drill down, which itself is not very difficult, but further simplifying it, you can ask a very precise question. Say, what is the cot out of this furnace in this site? And it would give you it would pull the relevant screen, give you the relevant information along with some of the associated information, and also from where it is picked up. Likewise, if you have from an engineering standpoint, if you have a whole lot of documents, you feed it the documents and your ability to really extract information, very precise information out of it, to get your data a lot faster rather than going and kind of taking a lot of time going through a lot of those documents. And now this is being done, still a little bit of work in progress on flow sheets, engineering data sheets, and as well as written engineering documents. So this is the kind of thing that the Gen AI, where it helps and takes it to another level, where the ease of use and user experience goes to a very different level. So the knowledge retriever, essentially, these Gen AI chatbots answering questions, is really what it's more of the user experience. It's taken to a very different level. Now, as some of you who would have used things like ChatGPT, you've heard of hallucinations and so on. This is where the main challenge comes in when we pull a system like this for very specialized application in the process industry. You need to make sure that those hallucinations are reduced. You have more repeatability. You have, more precise answers coming in. So being able to do that through, whether it's through agentic RAG, and there are a lot of techniques, there's a lot of effort, and that is something that we are doing a lot of work on. And we have done some pilots in that area with some of our customers. So this is kind of just to give you a very quick glimpse into this whole area of how AI is being applied in our industry, and where it is headed as you go down the road. So my last slide here is just a overview of the type of benefits that we've seen from implementations that we today have, across these several facilities, across several geographies. Certainly, we've been able to get that value, and hence a lot of our implementations have gone beyond pilots and so getting that value is so important. And oftentimes, even if you get value in a pilot, being able to do it in a larger scale takes some very different abilities. And so that is something, if you take care of these fundamentals, some of which I shared, end to end, more robust more comprehensive way of, training and testing and pulling things together, you're fairly ensured that your scaling happens a lot more smoothly. Of course, there is a people aspect and transformation aspect, which I haven't really touched upon a whole lot, but that also goes hand in hand with this. So with that, I think this is really what I wanted to share today with all of you. And I would open the floor for questions.
Hello. Anyone in the audience got questions, please?
Sir, this agentic AI and agentic AI, is it similar to genetic algorithms?
And it is a genetic algorithms would be a subset. It's not genetic is one part of it. Agentic AI, the concept, like I said, is really pulling together various different algorithms, different agents together to really deliver an objective that you've given it. You could just say, I mean, in our day-to-day life, an easy example is you want to travel to say another country, and you want all your travel arrangements made, and you say, make those arrangements, and you specify these are kind of what I'm expecting, and it comes, does the bookings and everything, and gives it to you. So that's the kind of thing an agentic AI, even in the process space, would do. You can define problems that something that otherwise a user may have to go and take multiple steps to do an analysis, get results, then feed it into something else, and take multiple steps. So this is where agentic AI comes in, and that was where my point came in. If you have done each of these individual steps, it becomes a lot easier to pull an agentic AI together that can automate this as well as improve upon it.
Okay, sir, got it.
Sir, for solving a particular problem, via the different model is available. So, is there any user-friendly interfaces available? So, any common person can have actually like the other software is available. Is it formation process, or can we use in the earlier one?
See, Ramesh, what like you're saying, even in you would have been familiar with process simulation, where as it evolved, there's more and more help available. So same way with these platforms that I was talking about, those platforms are evolving very fast, and so this is where when I talked about not just a generic platform but a very specialized platform, if we're trying to get to a point where a user can start utilizing that platform to pull the right algorithms to solve a particular use case. So the algorithms will assist in if a person who wants to do that with suggesting, hey, this is the best algorithm to use for what you're trying to do. So today, if you go to a generic data platform, something like that is not readily available for specialized use cases. But more and more of that is coming in. You're beginning to see that in banking verticals, in finance verticals, and we are of course doing a lot of that in our process manufacturing vertical. So the answer is it is evolving, and it is still not something that a completely a fresh person coming in, finds it very easy to do.
Okay, sir. Thank you.
Sir, implementation of all these AI in chemical industry mostly depends on the development of waste quality sensors. So what is exactly happening in that field?
It's a good question, because at the end of the the data that you are able to pull in is very important. And so in the ideal world, for any particular use case, as a chemical engineer, you would know, say, for this use case, I ideally need this data. But in the real world, that is not always available. So yes, once you have, if you put all the sensors to get all the exact relevant data, it becomes a lot easier to solve that problem with the models. But reality, oftentimes there would be budget constraints. Those in the industry would know. So people start prioritizing, and not all, maybe they'll put a subset of those sensors. Two, even after you put the sensors are notorious for falling off, and you get errors in the readings. So there's obviously it has to be maintained, but sometimes it's not always in real time. And so this is where, yes, while the sensors are very important, this is where the AI also plays a role with the soft sensors, where, like I said, the soft sensors and the error handling in these more specialized data platforms for our industry, you try and handle a lot of that so that one error or one sensor drift doesn't throw the whole thing, blow it all apart and say, I throw your hands up, I can't do, I can't compute. So yes, sensors are very important, but AI is a way to actually also take care of the reality of these sensors.
Thanks, sir.
Uh, Sir Rajesh Bhatkar from Petrofac.
Yes, Rajesh.
I'm from EPC oil and gas background.
Yes, I'm familiar with Petrofac. Yes, Rajesh.
So what interesting aspect I see, 18% increase in production. So what is interesting is that when we quote for oil and gas plant, so it is a multi-billion-dollar plant, and by providing design for 18% increase in production, EPC contractor will not get any additional bonus. Whereas the risk is, if we don't give 100%, we get for even the 1% reduction, 10% penalty. So last 2 days or 3 days, what we saw that this AI for operation, improving operation, debottlenecking operation, or process control. Yes, there is tremendous advantage for that. But what I see when we quote, for multi-billion-dollar project. So as a process engineer, I'm working as a senior manager in process design in last about 20 years in Petrofac. So to mitigate that error, like quality giveaway, what we say that for penalty giveaway, we build margin on margins or mismatching the margins. On one equipment, yes, I'm sure I'm providing 10%. But if it is a what we say called oil and gas, oil and water system, which are very tight emulsion, there I'm not sure. I may give more margin there, and that is direct increase in cost. So if you work in, closely with the EPC contractor, like this, you are aware of many international contractors, Petrofac, L&T, they are in India. So if you work with these people to build process design, which is fit for 100%, and looking at whole plant process guarantee, we don't give more than 10%. That is a substantial increase in that plant cost. So by that, not only we reduce the risk of applying penalty, 10% penalty, but also if you can minimize the cost, winning the project itself is a big advantage. So what I'm saying is that AI model should be built while designing the process equipment. What we saw now, that plant is operating, so how to operate in a best way, debottleneck the issues, or control it to the best optimize parameters so that you get a maximum productivity, best energy, reduce environmental problems. What I'm saying that build the equipment what is fit for the purpose at the reasonable cost, increasing the possibility of the winning the project, that multi-billion-dollar project, as well as reducing the cost of or reducing the risk of penalty. So is it possible to apply this concept why for the process design as compared to the operation or control of the project?
Rajesh, to answer your question, I mean, certainly we also do a lot of engineering, so I'm very familiar with this area. See, a lot of the engineering companies, I mean, today, even in the last 20 years, designs have been done using a lot of, process simulation, equipment models and so on. So designs are anyway being done using the process simulators. It's using simulation for design is very different from using the simulation or even data-driven models in an operation environment. When you're designing, a lot of the engineering companies, what happens, certainly uh, you can be very, very tight and design exactly to without any level of tolerance. But in reality, that doesn't happen because uh, there is this we have seen across facilities, over the times. There's a lot of fat that is put in there, like you also alluded to, and that happens because you want to that comfort level has to be there because at the end of the day there is that leeway is given so that when there's the performance test that happens, you want to make sure that you are able to deliver on that. So engineering companies have always put this fat into the design, these tolerances, what do you call it? And that varies. Some are tighter than others. Certainly, there's a cost impact to that, but somehow it's the whole risk of not being able to deliver seems to take precedence over a little bit of extra cost. So this is where that fat comes in, and this is where on the operations side, when we start modeling and we are able to kind of push more through, even without doing any kind of changes to the process or adding equipment to a certain level to utilize this fat up to a certain level, subject to safety. Now, the next thing is debottlenecking, where okay, hey, this one equipment is bottlenecking this whole increase. So you go debottleneck that, and then you look at the next bottleneck, and so on. So in that sense, simulation and one part of AI has always been used in our design. The data-driven part is typically would kick in more on the operations side. Now, there is another loop over all this that today, I mean, we're having these kind of discussions where once you are very familiar operating this facility and you have modeled the operations of the facility, you also get a lot of insights into how the design can be made more efficient. That is a feedback loop that can go to the likes of Petrofac or L&T and people who are actually designing these facilities. So that is the part where this kind of AI modeling can help. There's a whole different set of AI digital twins and so on, but that is more on the coming out of the 3D models and ability to really look at the physical asset, model that and visualize that a lot better at the design phase itself. So there are a whole lot of applications in the design phase itself to help. But a lot of that is from the visualization standpoint, but the base techniques, a lot of that have always been there. I think it's more of the risk perception, and that has always put this level of tolerance. Even in taking an analogy on the operation side, if you look at way people operate plants, you have a certain specification, and a lot of the times there is product giveaway. So you specify there's only so much impurity that can be there, and a lot of the plants, just to be absolutely safe, they will over purify. So that's where these APC, is trying to become better and better to try and reduce that tolerance level. So I think that's the crux of what you're looking at. Certainly, there are a lot of improvements that can happen there, and aspects of AI which have already been practiced can certainly be utilized. But it's at the end of the day the workflow and the thought process and risk management that is really what matters to make this happen beyond the technical.
Thank you, sir.
Hello, sir. I had a doubt. Am I audible?
Yes, I can hear you, Aditya.
Yeah. I just had a question since we are speaking about process optimization and let's say you have a plant and let's say you have already trained a model. It's going on for a period of 2 years and you have managed to achieve whatever your desired profitability was, you have managed to reduce operating cost, etc., etc. So how do you identify, like, let's say the plant, each plant will depreciate in terms of its functionality and value. So can the AI also predict the rate at which it will depreciate in terms of profitability, or will that require a separate model to be developed?
So when you're developing these models, I mean, you can have a very simple model that has to be because in the plant, things are there are two types of changes. One, you have environmental changes where maybe the feed quality or the demands, those change, and so that is one thing that the process model, or whether it's data driven or this thing, is something that you try and model, looking at how those changes impact the behavior. um, the other part is like you exactly said, things foul, and with those changes, what the impacts are. So the training, it has to be trained to understand that. In a fundamental model, again, if that has been incorporated, those set of equations have been incorporated, you're able to model that and you're able to predict that. Same thing with data-driven models. That level of training has to be given. Even if you may not have real data, you can train it with synthetic data based on how you expect, based on your fundamental understanding, how those kind of changes can impact this thing. So if that is factored into and the model is trained for that, certainly that is also something that the model can predict. If not, the model will have to be retrained for the conditions which it has not been trained for it to be able to really even run in that kind of a domain.
Thank you,
Sir,
sir.
there are two questions in the chat box. I will read it, sir. Hello, sir.
Yes, Ramesh.
Yeah. I will read it, the question in chat box. Prasad asks, while implementing the AI-based predictive analysis, how can any process manufacturing company balance the trade-off between model complexity and interpretability? What strategy can these companies employ to ensure high-quality data? Can I read it again slowly?
Yeah, please read it again.
Okay. While implementing AI-based predictive analysis, how can any process manufacturing company balance the trade-off between model complexity and interpretability? What strategies can these companies employ to ensure high-quality data?
See, the complexity of the model, yes, at some point you have to draw a line between particularly if the increased complexity of the model is going to impact, say, the response times and things like that, or even the you don't want it to crash often for not being able to complete a computation. So that is where you draw the line on how complex it can get. Now, the interpretability, that's a very interesting. In machine learning, that was one of the big drawbacks earlier on, because it was almost like a black box. And so this is where having, there are now techniques where you are able to actually follow and interpret really why some of these things are being done. The other way of also an additional way of handling it, which we have also tried, is having you have the luxury of having fundamental simulation models. That also helps to some extent. So these go hand in hand to be able to do that. In terms of data quality, like I said, you would, I mean, when we implement some of these things, there are some data points where you say it's extremely sacrosanct to have, and you maintain it. It has to be on your priority action list to keep maintaining and making sure those sensors provide that data. I mean, it's a non-negotiable item. But you try and get that to the smallest set that is possible, and but if you do that with all the data that is required, then it becomes very unrealistic. And so this is where the soft sensors, you're trying to utilize models even to kind of, if some data point goes off, you're still able to run it. So the data quality is very important in any particularly data-driven models. But these are some of the ways you work around it. And in the plant environment, this is how we have worked with manufacturers to do this, to address this.
Thank you, sir. One again participant asked the question, that is the Sania Sayed. What are the scalability challenge when deploying the agentic system at scale?
Yes, so like I said, I mean, those 3 steps that I showed, it really came out of seeing some of the people directly jumping in and trying to put in an agentic AI system right in the beginning. A lot of the challenges, yes, once you've actually done, I mean, all these things that I mentioned of, doing the proper training, the testing, and after all the robust thing is handled, even then, there's a people side to it. Being able to make sure you get the buy-in, and that has to happen very early in the project. And there has to be a collaborative way of working so that ultimately the end user should be involved very early, is charged up to utilize and keep improving upon this. So the biggest challenge with agentic AI has been, I have seen in a lot of applications, is where the same things I've mentioned, people have been very, very technology driven. They haven't taken care of these aspects of making sure it's end to end, and a lot of domain intelligence has gone in to make sure it is a very robust system that you're working with to start with. And second is, if they haven't really tried to work through this themselves, they get a black box effect, and they're very quick to dismiss it and turn it off. So there is a little bit of that people aspect, even if it's running very robustly. If they have not been involved, or they're not aware of, okay, this is what is happening inside. So if they have actually gone through that, using each individual agent and utilizing it as part of their workflow, and then it is automated, it's a lot more likely that they're comfortable with it and have the confidence to continue with it. So these are some of the challenges we have seen, and so this is kind of I mean, what we are seeing and how we can get around it.
Anyone has got any questions, please? Okay. So thank you very much for this insightful presentation. Your expertise on application of AI in process manufacturing was a major highlight, and I'm sure all of us have enjoyed your presentation, and we are very appreciate you that you shared your information, your knowledge with us. Thank you, sir.
Thank you, Nitin. Appreciate the the opportunity to share my thoughts here.
Thank you very much.
Thank you everyone for listening.
Thank you.
Thank you, sir.
Bye. Bye.
Bye bye.
Okay, thank you, sir.
Thank you.
Thank you. Thank you very much.
The participant will meet. Nitin, announce the 6 o'clock.